Hello, and welcome to Properties of Logarithms. We're going to get into some basic properties here because this is an intermediate algebra approach. Let me just slur through that here. Intermediate algebra approach. Let's start with the big three. I call these the big three. We had the basic three before. These are the big three properties. The product property. Log base b of m times n is log base b of m plus log base b of n. And we think of this really as if we had b to the m multiplied by b to the n, right? If we're multiplying two things with the same base, we add their exponents. But remember, all a logarithm is an exponent. So we add the logarithm. So multiplication turns into addition. Similarly, the quotient property, log base b of m divided by n, is the same as log base b of m minus log base b of n. And why is that? We have rules for exponents that say if we're dividing two things with the same base, that n is not looking all right for me, but we're going to keep it there. If you're dividing two things with the same base, you subtract their exponents. All a logarithm is an exponent. The power property says log base b of m to the r power is r times log base b of m. And why is that? If I have b to the m to the r power, right, an exponent raised to an exponent, I multiply. And one way we could look at all of these kind of together is through our order of operations. Oops, make that a D. Almost turned it into an A. Our order of operations, PEMDAS, parentheses, exponents, multiply and divide, add and subtract. Here's how I think about it. If you are multiplying two things with the same base, you add their exponents. It's just kind of a step down on the order of operations. If you're if you're dividing two things with the same base, you step down into subtraction. So, okay, that makes sense. They're lined up over each other. The power property, if you have an exponent, a power, and it's raised to a power, so if you have an exponent raised to an exponent, you multiply. So everything's just kind of one step down on our order of operations. So notice that here, there's nothing to step down to. So if I have log base b of m plus n, that's it. It cannot be simplified. End of story. I'm going to write here, no simplification. All right. So there's nothing below add and subtract. There's nothing we could do. But if we're multiplying two things using exponents, we can add the exponents. If we're dividing, we can subtract the exponents. If we have an exponent raised to an exponent, we multiply our order of operations that we carry with us. Just takes care of all of that at the same time. So let's use these properties. And keep in mind this equal sign tells me I could go from left to right or from right to left. So we're going to know this. We're going to learn this forwards and backwards. That's how we know we know something. All right, here we go. And let's hope I have enough room here. I believe I do. Okay, so first, expand the following logarithms as separate, simpler logarithms. Always start in these examples. I'm going to start with product and quotient. And finish with the power rule. So I notice I have log base 7 of 4 times a to the third times b squared. Now I said times kind of weird, right? Why? Because I'm emphasizing the multiplication. So our first step using the power rule says this must be log base 7 of 4 plus log base 7 of a to the third plus log base 7 of b squared. All right, that is all product rule. That multiplication 4 times a to the third times b squared ended up in separate logarithms with addition. But now, this log base 7 of 4, we could use our calculator if we wanted to know that decimal, but we don't care right now. What we're going to do now is use the power rule that says we bring this 3 down in front. We bring this 2, this exponent, right? Instead of an exponent, we multiply in the front. So we'll have 3 log base 7 of A plus 2 log base 7 of B. And this, as it turns out, is our answer. So I'm going to write right here, that was the power rule. All right, so first we did the product rule to rewrite as sums of separate logarithms. And then we used the power rule. Remember, all an exponent is, right? A to the third, that's just A times A times A. What's repeated multiplication? That's addition. Well, okay, instead of writing log base 7 of A plus log base 7 of A plus log base 7 of A, isn't it easier just to say, hey, we have 3 of those? All right. Next example. I'm going to scroll up a little bit and keep it our main focus. The first thing I see here is a quotient, right? I see a division. Notice no base is written, so it's base 10. So I'm going to take log of the numerator minus log of the denominator. Entire numerator, that 2x to the 5th, everything in the numerator is in our first log. Everything in the denominator is in our second log. Division turns into subtraction. So this is our quotient rule. Next, I'm going to expand this part, right? What is that? That's log of 2 times x to the 5th. So that's log of 2 plus log of x to the 5th. We still have the minus log of y cubed. And parentheses are always a good idea. I get lazy sometimes. Okay, so now there's just a 2, there's just an x, there's just a y. We've separated everything through subtraction and addition that we needed to. I'm going to put here product. Now I'm going to use that power rule, and I'm going to take this 5 and put it in front. I'm going to take this 3, I'm going to put it in front as a coefficient, and we'll have log of 2 plus 5 log of x minus 3 log of y. This is our final answer. All right. Don't make it harder than that. Take it a step at a time. Pow. I'm going to put a dot there so it's power rule. Why would I abbreviate power instead of just putting 2 more letters? Okay. Last one of this type. All right, we're tearing these apart. So a little reminder over here. If I have the square root of something, that's the same as the 1/2 power. So the first thing I'm going to do is I'm going to rewrite this as log of 11 a to the 3rd b to the 9th c to the 1/2 power. And now I have the choice. I could either simplify algebraically and give the c the 1/2, the b to the 9th the 1/2, the a to the 3rd the 1/2, and the 11 to the 1/2 power. Or I could simplify logarithmically and just move that 1/2 out in front. As you progress through math, you'll find that this is definitely a good idea. I always take, if it's a radical, throw that 1/2 in the front, get rid of it, deal with that later. So now we'll break it down into, we have the 1/2 out in front multiplied by all of this. Notice these are multiplied, 11 times a to the 3rd times b to the 9th times c. So that's log of 11 plus log of a to the 3rd plus log of b to the 9th plus log of c. And that 1/2 goes with all of them. I'm going to keep that 1/2 there. All right, so first we use the product rule. I'm going to leave that 1/2. I'm going to leave log of 11. Now I'm going to move that 3 out in front, so we'll have 3 log of a. You'll notice frequently, if it's just a variable or just a single digit number, I don't use parentheses. If it's a double digit number, I want to keep that 11 together. I want to kind of give it the parentheses like a hug, keeping it close to the logarithm. 3 log of a, no parentheses. 9 log of b. It is not wrong if you use parentheses. I find that sometimes I'm just lazy. And now we can distribute this half. We're going to call this the power rule because that's what it is. And this is just simplify. That's 1/2 log of 11 plus 3/2 log of a plus 9/2 log of b plus 1/2 log of c. We no longer need parentheses except for around that 11. Just to give it that nice warm hug, that nice belonging to the logarithm. And this pure simplification step, that's it. It's going back to algebra, regular PEMDAS, not the exponent rules. All right, so that is expand, but remember equations go both ways. So now we're going to do the opposite. Now, as we do the opposite, I want to show you something here in example number 2. See how the log of 2 has no sign out in front, so it's assumed to be positive. 5 log of x is positive. 3 log of y is negative. Where was the y? Denominator. Where was the x? Numerator. Where was the 2? Numerator. If it comes from the numerator, it'll be a positive logarithm. If it comes from the denominator, it'll be a negative logarithm. Why is that? Because a negative, right, takes something to the denominator. A negative exponent takes something to the denominator. Or if it came from the denominator, negative exponent. So now when we write the following logarithms as a single log, we're going to start with the power rule. We're going to go completely opposite and end with product and quotient rules. All right, so we do it just opposite. The first thing we're going to do, we're going to take this 4 and we're going to put it on an exponent of a, and we're going to take this 2 and we're going to put it on as an exponent of b, and we'll get log base 2 of 7 plus log base 2 of a to the 4th plus log base 2 of, oh, that's not a 2, that's a b. My hand was getting in front of my brain. A log base 2 of b squared. Now, notice all of these are log base 2, right? Log base 2, log base 2. They'll combine to a single log base 2. Our first 3 examples, the base stays with the logarithm. It's a descriptive term for the logarithm. It tells you very important information. So we have to keep that log base 2, log base 2, log base 2. Don't forget about the base. All right, so first we use the power rule. Next, we're going to combine 2 at a time. So I'm going to combine these 2. Addition turns into multiplication, right? That's log base 2 of 7a to the 4th plus log base 2 of b squared. And then we can combine these 2 to give us log base 2 of 7a to the 4th b squared. All the logarithms were positive to begin with, so we have no denominator. All right, all we're doing is going backwards on the 3 examples we did on the previous page. All right, let's try this again. Let's start here. We're going to take the 2 and put it on as an exponent of the 4x. Both the 4 and the x get it. Take the 3 up and take the 5 up. So this is log of 4x squared plus log of z cubed, I'll always cross my z's, minus log of y to the 5th. Now over here, I'm going to do a simplification step. If I have 4x squared, that is 16x squared. And we know that through exponent rules as well. But I just want to show you. So in simplification, that's it. This is only simplification. This is power rule. Log of 16x squared plus log of z to the 3rd minus log of y to the 5th. So I always simplify. I don't like to have several things raised to a power. I want to get that simplified and get it as compact as I can before I move forward and use a product property. Let's keep that in blue. This is log of 16 x squared z to the third minus log of y to the fifth. And I'm going to take this up to the next column over here. That's all I did, use the product rule. And now I'm going to use the quotient rule. Let's call this quotient rule. The quotient rule says now that I have a log minus a log, same base, that's log base 10 of the quotient, where 16 x squared z to the third is in the numerator and y to the fifth is in the denominator. It was negative, so it goes downstairs. Negative attitudes, they go downstairs. Get over it. 16x squared z to the third in the numerator, y to the fifth, and the denominator kind of jives with the signs that we have, positives on the x and the z, a negative in front of the y. Everything looks pretty good. Now, I haven't yelled at you to pause yet, so I'm assuming you're pausing as we go along and making sure everything's going along, that you're able to do this too, because that's the key. You can watch me do this all day long, but man, isn't that boring? All right, so first step, I'm going to use the power rule. So I have log base 4 of 5 to the 1/2 plus log base 4 of a to the 7/2 minus log base 4 of c to the 3/2. And no matter how much silent and do not disturb I turn on, I always have something that goes off at some point on my phone. Okay, it's time for me to wake up. I'm awake. Log base 4 of 5 to the 1/2 plus log base 4 of a to the 7/2 minus log base 4 of c to the 3/4. So now I'm going to use a product rule. I'm just going to take two at a time. Log base 4 of 5 to the 1/2 times a to the 7/2 minus log base 4 of c to the 3/2. Now I'm going to use the quotient rule. What is that? I can't spell quotient all of the sudden. I think I have to start from the beginning. Let's see. Quotient. There we go. The quotient rule says now we're going to divide these. Log base 4, 5 to the 1/2, a to the 7/2 over c to the 3/2. And this is a great answer. This is a fine answer. You can keep it. This is a good keeper. But for those of you that are wondering, see all those halves? We had that earlier, right? In example 3 of the previous. So we could take a simplification and rewrite this as log base 4. We know everything's under the square root. So now we've taken care of, with that denominator of 2 in the exponents, we've taken care of the radical. Now we'll have 5 a to the 7th over c to the 3rd. So this is a great answer too. Make sure that is a 7 and not a 2. Either answer that we have down here, they're both fantastic. If this last step makes sense to you based on example 3 from the previous page, fantastic. If it doesn't yet, keep working on it. This might be the first time you've seen logarithms. They take a minute, but once it clicks, they can be as straightforward as I hope I made them look. That's it for this video, Properties of Logarithms. Thanks for listening.